is very long. So the task here is how many character comparisons will be made by hospital string search algorithm if we have a median 0 as the string and we have these 3 different patterns. I'll give you maybe 2 minutes to work on these 3 examples. You may only choose 1 or 2 examples if you don't have enough time to go through all of them, and then we're going to go through all of these together. And remember that in this question, we want to find the concrete number of comparisons for each case. So you may need to do the first few comparisons first, and then try to find the idea behind it, and then maybe you want to generalize a formula for calculating the number of comparisons. All right, let's work through the first example first. We have a median 0 as a string, and the pattern we have here is 0, 1, 0, 0, 1. So firstly, the lookup table. We'll need to process through 0, 1, 0, 0, these 4 characters one by one. And for the other cells, I think they will have the default value equals to the string length, equal to the pattern length, which is 5. And then for the first character 0, I think we're going to get a 4. Then for the second character 1, we get a 3. Then we're going to have another 0, and we get a 2. So we will overwrite the value in the table. And then for the last 0 here, we're also going to get a new value 1. So we will eventually have the entry 0 containing value of 1 and the entry 1 containing the value of 3. Now let's do the comparison. The first comparison here giving us a mismatch. And since it's a mismatch, we're going to look for 0 in the lookup table. And we get a 1. That means we're going to move the pattern to the right for just one single position and then perform the next comparison. The next comparison is another mismatch. And we get another 0 here, so we'll move the pattern for one single position. So I think what we have here is we are going to have one comparison each time after we place the pattern to a new position. And then after that comparison, we get a mismatch, and then we're going to move the pattern for one position to the right. So we're slowly moving the pattern one single position each time until the end of the string. So the last comparison we're going to make would be here. And in order to find out how many comparisons we have made, I think this time it's quite clear that we didn't make any comparison on the first 4 zeros, but starting from the 5th zero to the last zero, we've made one comparison on each of these zeros in the string. So the total number of comparisons would be 1,000,000 minus 4. 4 comes from the first 4 zeros that we've never touched. For all other zeros, we made just one single comparison on each of them. All right, let's move on. The second question, in question B, we have a pattern 0, 0, 0, 1, 0. So again, we'll first need to work out the lookup table. And I think in this case, 0 will have a value of 2, 1 will have a value of 1, and any character that's 2 or 3 or any other character would have the value of 5. Then we will do the comparison. So the first comparison is 0 with 0, that's a match. So we'll move on to the second comparison, giving us a mismatch. And since we get a 0 here, we're going to move the pattern for 2 positions. Then I think we're going to have the same idea. There will be 2 comparisons that we're going to make. The first one giving us a match, the second one give us a mismatch. And since it's another 0 here, we're going to move the pattern for 2 positions to the right. And this will give us the next 2 comparisons. And I think this is clear that every time we're going to make 2 comparisons, and then we're going to move the pattern for 2 positions. And after several movements, I think our pattern will be placed here, and we're going to have the last 2 comparison made here. Now, if we consider the zeros in the string that we've never make a comparison on, we have the first 3 zeros and the last 0. So we have 4 zeros that we have never touched. And for all other zeros, we've made exactly one single comparison. So we have another 1,000,000 minus 4 number of comparisons. Now for the last pattern, again, we'll have the lookup table. For 0, we have a 4. For 1, we have a 1. And in this case, I think we're going to have a comparison here. That's a mismatch. So we need to move the pattern for 4 positions, giving us 0, 1, 1, 1, 1. Then this will give us the second comparison. Another mismatch. So we will go into move the pattern 0, 1, 1, 1, 1. And one more comparison here. So we're going to make one single comparison and then move the pattern for 4 positions until our pattern reaches the end of the string. And in this case, it might not be so obvious where do we place the last pattern. But I think we can use other strategies to find it out. If I add index values for each of the zeros in the string, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Now I think we've made a comparison here at index 4, index 8, index 12. I think it's reasonable to assume that the next comparison we're going to make would be at index 16. Because remember that we each time move the pattern for 4 positions. So we make comparisons at index 4, 8, 12, 16, 20, 24, 28, 32, and so on. They must be multiple of 4. And I think the last comparison we are going to make would also be at an index value that's a multiple of 4, and it has to be smaller than 1 million, because we have in total 1 million characters. And the number of comparisons that we're going to make in total would be 1 million minus 4 divided by 4. We probably don't have enough time to illustrate how we get this, but I think if you try to count 4, 8, 12, 16, and to 10 to the power of 6 minus 4, it shouldn't be too challenging for us to find out how many values are there in this sequence. And I think you're going to get 1 million minus 4 divided by 4, which is roughly 249999. Which is exactly 249999. All right, that's question 69. And in this question, we've evaluated that a string containing 1 million zeros and then 3 different patterns. And we can see that with different patterns, we may end up with different number of comparisons.